Hi, my name is Matt Runkle, and I'm a student in the Digital Forensics course at NYU here. And I'd like to walk you through my final presentation on what I'm calling the Packet User Database, which is actually built on a previous student's work here. So I've always been interested in network forensics, and anything that you can do to parse network captures that you have to get to the interesting information quicker is more interesting. And we actually had an assignment earlier in the semester where we walked through the fictional University of Nitroba to figure out which student was sending harassing emails off to their professor by kind of sleuthing through a lot of the data we've captured to kind of narrow down on a particular student, even though there were multiple students using the same internet connection and therefore from the outside world looked like they were the same person from that IP address. So this tool is actually the Packet User Database, which was built off of something by Eric Herashevsky. Hopefully I said that right. He took Natroba as an inspiration and kind of worked through a way to reconstruct TCP connections and sessions and then try to identify particular users based off of metadata at the application level in order to get around that VPNs and NATs and any of those IPv6 to IPv4 translations that can kind of mask users behind a single IP address. So this tool is generally going to help you try to make these investigations a lot easier than manually working through a Pcap file. So really what we're trying to answer here is, who's talking to whom, and then what are they saying to each other? And that's kind of what I took from that assignment. And Eric had a great start to this, and I wanted to add a little bit to it to expand it to be helpful in a broader sense. So Eric started off with the ability to read in a PCAP file, reconstruct those TCP sessions so we can come back with the transactions between the user or on the client side and the server side to be able to separate out which requests were going out to the server and then what the server was sending back, so we could actually come up with what data is coming from each side and put that all together to see what they saw. It also brought in the DNS data, was able to kind of pull up DNS packets it saw and then tried as best I could to match it up with the request going out, so we had a little semblance of which IP addresses we're going to, that we're mapping to which URLs. And then again, using that application layer data at the HTTP headers, like user agents, language, cookies, refers, those types of things, all within a certain, and in this case, 120-second window, to kind of reconstruct the sessions and said, that's good enough to be coming from a single user using that data rather than just that IP address. And he also had this neat feature here to actually decompress gzip payloads. You can get at, a lot of web servers will do compression to speed up your connection. So he can take that out and then reconstruct and actually see what your payload is. So, JSON and any other objects you can get there. So what I wanted to do is I added on top of that the ability to reconstruct full email messages. So in the Natroba case, going back to that assignment, that's particularly important to us. In that case, a lot of the clients were using web browsers in order to access webmail. But if the person happened to be using a like Outlook or some other mail client on the machine, we wouldn't have been able to see that web connection as easily. We'd actually have to go through and parse your SMTP connections for sending the mail or IMAP connections coming back. You could use POP as well, but IMAP is the preferred solution at this point. So I added support for both of those, so you could actually come in and reconstruct full emails, including the attachments if there are any on either side. And then the ability to take those attachments and then reconstruct them and save them to disk, so we can do some forensics on those. And broader than that Natroba assignment, if you're on a corporate network and you're seeing some data left your network and you're interested in how that happened, if you have captures here, you can kind of narrow in on maybe some email accounts that were compromised, and then figure out if the attachments being sent out, because you can reconstruct them, if that was full of potentially sensitive information that was exfiltrated off of your network, which could help. And then in order to aid in more investigation, I added some VirusTotal integration. So VirusTotal is a great online source that aggregates a bunch of virus scanning technologies you can put in there, so you can actually submit files to it, and it will tell you if it's malicious or if it's been seen before, and it will give you a report back from a ton of different virus checkers. They also maintain databases of like DNS mappings, IP addresses that are malicious or serving malicious content. So you can actually go up and look up how trustworthy is this IP address. Have we seen anything bad from it? So if you run across a IP address that looks kind of suspicious in your capture here, you can go out and kind of ping that and see what's going on. So those are the main features that I added there, and just kind of like built this all on top of what he's already put in. And I'm going to show you a demo of that in a couple seconds here. But a couple of ideas I had when I was actually coming up with this presentation today was, if anyone wants to work in this in the future, and if I have some time, I will definitely do that. So check out this URL here, or I'll keep the up-to-date work that I'm doing on this. But you could also have it extract downloaded content. So just instead of just email attachments, why not check out what the user has downloaded if that's come across your network, and maybe search only, say, PDFs or executable files. So that way, if someone is tricked into going online and downloading something that's actually malicious, you could actually figure out where that originated from if you have your network capture here. Instant messaging might be an interesting way to look at. Skype or IRC or something like that would help. And if you're an enterprise kind of level, the ability to import a cert and then decrypted SSL. Most services now, especially instant messaging, a lot of email clients and stuff use SSL and TLS encryption at this point in order to kind of obfuscate that. But if you're on an enterprise, you may have it set up so that you can decrypt it with your own cert. So that would be a good way to do it. But enough with this. Let me jump into the demo, and I'll show you exactly how this stuff works. So it's all command line at this point, and built on top of what Eric has done previously. So using the magic of demo, I've pre-compiled the Natroba, in this case, report in here. It took about a half an hour to parse all of that. So in this case, I'm just kind of running the summary function. This is something Eric put in. It was already here, but just to give you an idea, there's a lot of traffic in there that was going through. I think it's like 50 megs of traffic. So, quick overview, this pops out all of the IP addresses that you've seen. If it figured out any of the DNS and resolved the URL, it throws it in here, and then some counts of how many outgoing, how many incoming packets. So you can kind of see where a lot of the information has gone, and which were the popular connections during that time frame that you're looking at. So a quick little feature that I added in here. So say we saw one of these IP addresses that kind of looks suspicious. We'll type that in. We can just say, okay, give it the IP address, this one that I've pulled out, and just give it this -verify flag, and that will send it off to VirusTotal. Like I said, it's this great little service here. You can go online, you can actually select stuff. They have a web interface, but they have a robust API. If you just sign up to their community, they give you a free API key. You drop it in to your own file here. There's some directions in the README, and it will use that to pull it up. So we just queried there, and it pulled back that information from VirusTotal, and we'll use the report functionality here now to pull out all the information we know about this IP address, which will then include any reports that have come from VirusTotal at this point. So we're opening the database, and it's going to pop it out. In this case, this IP address didn't happen to show up in that IP or the Natroba data set here, but I picked it because it actually had some pretty good detections here, and I can demonstrate that. So normally you'd see the IP, if it was a source IP, you'd see information about it here. If it was a destination, you'd see information here. And in the VirusTotal report, you could see that this IP address has most recently been associated with what looks like some Russian sites. And out of the 52 different detectors that VirusTotal was using here, on the first one here, 2 of them detected some positive bits, and 3 for the second one here. So there's a couple of places that think these sites might be a little sketchy. So you could go dig into that further, or figure out exactly. There's some further report you could figure out that would actually be in your database, which we could show you later, and figure out which services are reporting that, and you may or may not trust those ones more than others. But that's completely up to the investigator, or the network administrator in this case who may be looking at this. But to further continue here, let's ingest a little sample that I have of some SMTP traffic. So that was just a Pcap file that I threw here of a web client trying to send some email out. And then we'll take a look at what's in there. So in this case, I say I'm an investigator. I have this report that I've just ingested, and I have an email address that I think is interesting. So I say, okay, let me see if I can find this email address anywhere here. So you just say report email, email, and the email address there. So it's kind of obfuscated in this case, lots of X's, but I see when I pop out here that a report for this email that there was one email that was sent from this address, and it's belonging to TCP stream 1, which is what we labeled it when it was ingested. Reassembled that whole stream, which is in the database now. I was just saying, okay, great. I think there's some attachments in there, but let's kind of find out here. So I can open up the database. I'll show you the two different views here. There are some other report functionalities that you can see that will show this out as well. But if you look at the SMTP thing here, see there's an email, and look, there's an attachment. And the message here you can pull up is testing attachments. You can dump that out over here as well. But I say, okay, so if there's definitely an attachment, or even if you don't know if there's attachments, you can do this too. And just say, take this, dump all the attachments from stream 1. I'm going to send the verify flag again, so we're going to send any attachments that we find off to VirusTotal to check them. And then the output file is a directory I've called attach dump. So it's going to go in there, pull up the database, reconstruct it, and says, all right, I found a file, I've submitted it to VirusTotal for you, and that file is called winmail.dat. So it was just attached there, probably an Outlook artifact of some sort. But if you go to your directory here, this is all of the entire program. An attach dump, you can see here, reconstruction on disk is this file, winmail.dat. So you could open it up, look at it, do whatever you want with it. It's the actual file there. And that was all submitted. So the reason it doesn't just pop the report back to you right away is, sometimes VirusTotal gets overloaded. It can take, they say in their API that it can take a couple hours if you're submitting a new file and they've never seen it before for them to actually get around to scanning everything and then actually coming up with a report. The API is prioritized the least of everything, so if you go to their website and upload a file, that gets priority. So I have the second reporting feature here that you can kind of go in here and check to see is it done, and if it's done, give it back to me. So it's just report any attachment, the attachment report for, in this case, we want the file winmail.dat, but you can give it the file ID or whatever else. We see in the report it's already come back. It's a small file, so it's easy. It'll give you the MD5 hash that was calculated by VirusTotal, the date at which it was last scanned on. So looks like it was scanned very recently I guess in their time zone, so it's tomorrow. Oops. And you'll see that it was detected by none of their 54 services that scanned this file, so this is probably clean, perfectly fine, not a bad file at all whatsoever, which is perfect for me, so I don't have to worry about that coming in. And just as kind of a final demonstration, just to prove that I can do this, here is an Imap Pcap file that I have. So this would be, say, your client is reaching out to the server to retrieve your email and coming down. So I'm just going to ingest this quick here. And we'll just do a quick filter on the database here. I'll open it up, call it Imap. And if you look in the SMTP directory here, you'll see there's a whole bunch of emails that it found all the way through here. And what's actually happening, because I happen to know what this data set is the client asked for a listing of all of just basically your header information, the envelope, if you will, from the mail server. So you're getting back just the headers of who sent what. So if you're thinking about it from your client view, just if you're looking at your email, this is just basically your inbox. So-and-so sent me this email. Here's the subject line. Here's the date that it came in that, and so forth. So it's not actually sending the entire message until you go click on it. And then at some point someone clicked on an email to open, and you'll see that here this one has a message that it pulled out of that stream as well, and it looks like it was a reply to some message, and here's the whole stream that came down. And it looks like there were no attachments in any of these emails. And that's pretty much it. So that's just a kind of a general overview of the stuff I've added. I would urge you to go back and look at what Eric created originally, and that's on the Cypher website. And you can see he has a whole bunch of other features in there that allow you to investigate HTTP traffic more. You can count email addresses if you see those coming across the wire. There's an interactive mode that you can go in and kind of play with this information through the command line and make that all work. And this is all just sort of integrated with that. So thank you for watching. If you have any questions, my email address was in the presentation earlier. It's matt@mrunkle.com. Feel free to reach out to me. And thank you very much.